So now we're ready to actually learn how to pivot in order to get our augmented matrix reduced. So when your book talks about the word pivot, about an element, the element that is circled needs to be the 1, and that remaining elements in the column need to be 0. So in the column, I guess I should say all other elements, all others are going to be a 0. So for our first example to pivot, they're asking us to pivot about the 2. So when you do the homework, they'll show you what element they want you to pivot about. And what they want us to do in this case is make this into a 1, then we're going to make this into a 0, and then we're done. So the idea is to make a unit column. And a unit column is made of 1s and 0s. So if they'd asked me to pivot about the 3, then I would have made the 3 into a 1 and put the 0 up there. Even though that's not the row reduced form, that's what the homework is referring to when they talk about pivoting. So we're going to pivot about this 2, so that I need to make the 2 into a 1, and then I'm going to make the 3 into a 0. So remember our rules. We can swap any 2 rows. We can multiply a row by anything that's non-zero, and we can add any 2 rows together. Well, to make this guy into a 1, what I'm going to do is I'm going to come in and take 1/2 of row 1, and that's how I write it. So it's 1/2 of row 1, and I'm writing it by row 1 to indicate I'm going to put the results back into row 1. In a minute, we're going to do some manipulations with row 2, and we'll write what we're doing by row 2. So when we do that, it's going to give us, so we're simply going to come in and take half of each number in that row. Well, half of 2 is 1. Half of 4 is 2. Half of 8 is 4. I'm just going to copy the second row over because we've done nothing to it yet. So there's the first row operation in our matrix. The next step then is to make this 3 into a 0. So to make this 3 into a 0, we're going to multiply row 1 by 3 and subtract it. To write it, we're going to say row 2 minus 3 times row 1. And we're going to do this pretty slowly to make sure we don't lose anybody and that it makes sense in terms of what we're doing. And I'm going to try and do a little bit of color coding to help with us. So I'm going to call this column A, this is going to be column B, and this is column C. So we're going to come in and take row 2, which is the 3, minus 3 times row 1, which is a 1. So this 3 is this 3. This 3 is my formula 3, and this 1 is this 1. Well, 3 minus 3 is 0. So I know I have a 1, a 2, and a 4, but now we've just created this 0. Okay, the next thing we're going to do is take row 2, which is a 1. We're going to subtract 3 times what's in row 2. Sorry, 3 times what's in row 1. So it'd be 1 minus 6, which is going to give me a negative 5. So now we're going to put a negative 5 right here. Let's make sure everybody's following what we're picking up and using. So this one is this one. So notice we're in column B. The 2 is coming from the first row in column B. So that's this 2 right here. So again, in case you're not catching it, this is my A column, right? This is my B column, and then the result is getting written in the C column. So then we're going to come in, I'm sorry. This is our A, this is our B, and this is our C. That would make more sense, wouldn't it? Think about that. So this is me manipulating row A, column A. This is column B, and here's column C. So we're taking the 2 that's right here, and we're going to subtract off 3 times the 4 that's right there. So this 2, and I won't color code again. This is the only time I'll do it. Is this 2, and this 4 is coming from this 4. So you can see a pattern, which is why we like doing it this way, because it's just a pattern. There's no guessing, there's no anything. It's just a pattern. So we have 2 minus 12, which is a negative 10. Now, as far as this problem is done, we're done, because we have a unit column. In the column they asked us to pivot about. Now we're not done with the entire problem if we were actually solving it, but as far as the directions on the homework go, we've done our pivoting and we are good to go on an answer. Let's try a little bit larger one. So now we're going to do a 3 by 3, a system of 3 equations and 3 unknowns, just for more practice. So this example, we have a 1, 3, 2, and a 4. We have 2, 4, 8, 6, and then we have a negative 1, 2, 3, and 4. Now we're going to go ahead and pivot about row 1, column 1. So let's go ahead and pivot that one. Okay. Well, it's already 1, so it's good to go. Not very exciting there. But we now need to make this 2 into a 0. So our first step is actually already done because it's already a 1. But we now need to make the 2 into a 0. So we're going to start with row 2, and then we're going to take 2 times row 1. So if I take this 2 minus 2 times this one, that'll make me a 0. We're going to write that in row 2. And notice that I wrote my manipulation of what we're doing by row 2. The first row you're not changing, so we'll just copy it over. 1, 3, 2, and 4. Okay, so we now have 2 minus 2, which is 0. We have 4 minus 3 times 2, so that's 4 minus 6, which is a negative 2. We have 8 minus 2 times 2, well, that's 8 minus 4, which is 4. We have 6 minus 2 times 4, so that's 6 minus 8, which is a negative 2. And as long as we're rewriting it, and we know we need a 0 down here, we're going to go ahead and manipulate this row at the same time. So we're going to take row 3, the row we're trying to make into a 0. This time, let's add row 1. So if I take negative 1 plus 1, I'll get my 0. And notice that when we're done with this manipulation, we'll have our unit column and be done with this part of the problem. Now we're going to come in and take 2 plus 3, which is going to give me a 5. We're going to take 3 plus 2, which gives me another 5. Then we'll take 4 plus 4 to get an 8. And we now have our unit column. And that's how you pivot about an element. So now I think we're ready to actually come in and do an actual complete problem using Gauss-Jordan. So this is example 3. The directions, and these are the directions from the homework. It says, given the augmented matrix, use the Gauss-Jordan elimination method to place the matrix in row reduced form. So we have 2, negative 1, and 1, 3, 2, 12. So again, our goal is to make this matrix look like this. So 1, 0, 0, 1, and then over here we'll have a number and some other number. We just don't know what they are, but when we get them, they'll be our solutions. So you can do a couple things. I want to do one with a fraction in it just to show you that not to be afraid of those fractions. You can also let your calculator do all the fraction work for you. Our first step is to get the 1 in the column. We need a 1 where we have a 2, so we're just going to come in and do 1/2 of row 1. And that's going into row 1. So half of 2 is 1. 1/2 times a negative 1 is going to give me a negative 1/2. And 1/2 times 1 is going to give me a 1/2. I'll copy over the bottom row because we haven't manipulated it yet. Okay, our first number is correct. It's right where we need it to be. Okay, now we're going to come in and we need to make the 3 into a 0. So again, what we're doing is we're pivoting this guy to make this into the 0. To get that is to 0, we're going to start with row 2 and do -3 times row 1. That's a row 2. So if I take 3 minus 3, I'll get my 0 where I want my 0 to be. I am doing nothing to the top row, so I'm just going to copy it over. So 3 minus 3 is going to give me my 0. I now have 2 minus 3 times the negative 1/2. Well, that would be a positive 3/2 plus 2/2. Well, 2/2 is 4/2. So that's going to give us what? I'll keep waiting on you guys to answer. That's going to give us 7/2. We have 12 minus 3 times a positive 1/2. So that's 3/2 again. 12 would be 24/2 minus 3/2. It's going to give us what, 21/2. Again, as far as I'm concerned, you can do all the calculator. You can do the fraction work on your calculator. Just make sure it's giving you back a fraction, especially if you have repeating decimals, you're going to introduce lots of rounding errors. So don't do decimals. So we have our first column. Yay! So now we move on to the next column. And in the next column, remember, you always want the 1 in the column first. So that means I need to manipulate this guy. So I'm going to multiply row 2 by 2/7. So 2/7 times row 2. Remember our rule or our hint, they always get the 1 in the column first. And if you're trying to get the 1, you usually end up multiplying. We're going to multiply by 2/7. Top row is not being changed, so we're just going to copy it over. So I have 1, negative 1/2, and 1/2. So down here, 0 times 2/7 is 0. 7/2 times 2/7 is 1. And 21/2 times 2/7 is 3, which is nice to see. We're almost there. Our next step is to come in and make this negative 1/2 into a 0. And then we'll have achieved our goal. To make that guy into a 0, what we're going to come in and do is take row 1, and I'm going to add half of row 2. Now, here's why you always do the 1 and then the 0 first. Because we've got a 0 sitting here, when I take 1 plus half of 0, it's not going to mess the 1 up. It'll still be a 1, which is what we need. So it'll give me a 1. Negative 1/2 plus 1/2 is 0. I have 1/2 plus 3/2, which would be 4/2, which is 2. And then we have our 0, 1, and 3. And yay, we finished it. So now we have our solution. So we know our solution is an x of 2 and a y of 3. I do recognize that for a system of 2 equations and 2 unknowns, that this may be longer for you in terms of a process than just using addition, elimination method or a substitution method. But when we hit the 3 equations and 3 unknowns, this is definitely a quicker route to the answer.